With the recent introduction of smart meters to British Columbia's existing power system infrastructure, we are going to be taking a closer look at smart meters in general. We will focus on the history of the technology, functionality, and some of the benefits that this new technology has to offer.
So what exactly is a smart meter, you ask? Well,
Smart meters are electronic devices that measure and record consumption of electrical energy. These meters play a significant role in the modernization of our electrical systems.
In the following section, I will describe how a smart meter actually functions. First, I will talk about the two main types of smart meters. Then I will go into the change in metering technology, more specifically in regards to the actual measuring of power. And finally, I will finish with how data is communicated from the smart meters to the consumer and the energy producer. There are two main types of smart meters: the self-contained meter for residential use and the instrument transformer meter for commercial use.
Outside an average household in BC, a self-contained meter will most likely be posted. Each meter has a built-in clamp that allows for easy installation into the standardized meter sockets. These meters are in series with the power flow, and as a result, if there is a need to change the meter, the customer must temporarily undergo an outage. These meters can handle up to 600 volts and 200 amps. Self-contained meters are preferred for residential use because of their easy installation and general lower cost.
On the other hand, larger commercial facilities utilize instrument transformer meters. Unlike self-contained meters, the energy flow does not entirely go through the meter. This allows for meter changes without the need of discontinuation of power. The instrument transformer meter makes use of voltage and current transformers to sample the usage of the customer. Moreover, these bulky meters can handle more than 600 volts and 200 amperes. Often, as a result of their larger size, instrument transformer meters are often found underground or in other secluded locations. Recently, metering technology has shifted from electromechanical meters towards electronic smart meters. Features of electromechanical meters include mechanical spinning discs that are used to measure energy consumption and communication via small dials. This process forced human inspection of energy consumption. Currently, electronic meters have dominated the market due to increased functionality, lifespan, and accessibility. Inside, there are no moving parts, resulting in less mechanical wear. Also, electronic meters display a digitized numerical analysis of electrical consumption and can wirelessly communicate to customers and energy providers.
smart meters have encrypted wireless communication technology, which allow for easy communication. There are two options of communication. First, it will prioritize and look for a nearby collector terminal hosted by the energy supplier. If a collector is available, the smart meter will process its data immediately to the box. If one is not within range, it will proceed to calculate a path through the other smart meters. As data flows through other meters, it will superset upon other meters' information.
In this section, I will be delving into the history and progression of the smart meter. In particular, I will be talking about the origins of the smart meter that trace back to the late 1800s, the development of the electromechanical meter into the smart meter, and finally, how smart meters are progressing around the world in countries like Canada, Sweden, and Italy. The smart meter can be traced back well over a century to the first known electric meter. In 1872, Samuel Gardner filed the first known patent on an electric meter, which was a DC lamp hour meter. A decade and a half later, in 1889, Elihu Thomson introduced his recording watt meter, which was the first true watt-hour meter produced. In the 1920s and early 1930s, there were many more changes to the electric meter, including a new socket-type meter and new standardized designs, making maintenance and replacement easier. In the late 1930s, a change was made in response to meters running faster after lightning storms. In the following years, improvements focused on reducing the meter size while increasing the calibration stability and accuracy of the output readings. Before the 1970s, electromechanical meters dominated both commercial and residential electricity measurement. With the heavy advancement of electronics during the 1970s, companies began developing electronic registers and automated meter reading devices. By the mid-1990s, after more electronic progress, manufacturers were able to produce and sell meters that were fully electrical, with no moving parts. As a result, manufacturers started to bring the production of induction-type polyphase meters to a halt. In the late 1990s and early 2000s, the smart meter was fully realized, with full two-way communication and higher measurement capabilities.
Many countries and electrical utility companies are now turning towards smart meters, including BC Hydro. The European Union is also planning to install smart meters in 80% of European households by the year 2020, with Italy being one of the first countries to roll smart meters out in the beginning of 2001. Sweden, Malta, and Finland have all finalized their rollouts and did so by 2013. Despite the seeming variety of advantages, many countries have also decided not to distribute smart meters or only install them in new or high consumption buildings.
So we can take a closer look at the benefits that this new system has to offer. The Smart Metering Initiative will enable BC Hydro to provide a host of new and improved services to BC residents and commercial users. These features include an improved safety and reliability system, enhanced customer service, and a reduction in electricity theft. Presently, the current electricity system does not provide any residential customer outage information to BC Hydro. In order to assess and repair faults in the system, crews must be dispatched to locate, diagnose, and mitigate the issue. This system is heavily reliant on customers to inform BC Hydro of an outage. In addition to improved safety, the smart meter's ability to capture more accurate and detailed usage information will result in more accurate meter readings, elimination of estimated billing, streamlined moving procedures, better informed customer service representatives, increased privacy, and reduced on-site visits. Currently, identifying and confirming theft is a time-consuming, inefficient, and expensive manual process. By augmenting current practices, the improved system for locating and preventing theft is twofold. Firstly, the new smart meters incorporated into the distribution system measure electricity supply to specific areas. These meters, coupled with sophisticated software, will help BC Hydro identify and address electricity theft more efficiently. In addition, the automated tamper detection feature in smart meters notifies BC Hydro if a meter has been removed from the wall or manipulated in an unexpected manner.
In addition, smart meters have greatly improved BC Hydro's operation efficiency. As we move forward into the next generation of smart grid technology, we need to prepare for the modernization of British Columbia's electricity system. Currently, BC Hydro transmits more electricity than the system demands. Increased efficiencies in meter reading, meter sampling, distribution system maintenance, and outage management will significantly reduce operating costs and consumer prices. By utilizing voltage information, existing control devices can be tuned for more efficiency. Using more accurate information results in reduced transmitted electricity amounts while maintaining the expected power quality desired by consumers. With the upgrade to smart technology, more diverse options are available in residential and commercial innovation. The improved telecommunications infrastructure will support advanced electrical system functions and energy applications like customer generation and microgrids. The system will also support large-scale clean energy initiatives. Smart metering networks will help BC Hydro manage innovative electrical systems such as electric vehicles, electrification of public transportation, community-based generation, and integration of renewable sources.
Ultimately, smart meters are a step towards the bright future of electrical systems.
Boots and cats and boots and cats and boons and kids and boons and kids and boons and kids and boons and boons and boons and kids and boons and kids and boots and cats and boots and cats.
Ultimately, smart meters are the step towards the right future.
Ultimately, smart meters are the way you go. The future rides upon us making the transition to smart meter technology.
We use ping pong power.
We support smart meters.
Who this?
I'm a nice dude.
The development of the electromechanical meter. The development of the electromechanical meter. The development of the electromechanical meter. Usually it's till 10.